In this video, we'll talk about unsupervised learning problems, and maybe we'll get to some various variations and generalizations of these types of this dichotomy. So this is a sort of artificial dichotomy, and there are various intermediate and generalizations of these types of classes of machine learning problems. So unsupervised learning, so that was supervised. Unsupervised is much less well defined. So for unsupervised, you're given just some x's now. I'll keep our superscript notation to denote the different points. X, these are not powers, these are not exponents, these are just the different points. So you're given these points, and maybe each x is in maybe in d-dimensional real space or k-dimensional real space or something like that. So maybe here, typically but not always, we might have xi in rk or something. Then, so that's e.g. But it could be something more general, like a document, or a string of words, or something else more complicated. So we're given this data, and the task is to. So if supervised was ill-posed or not completely specified, unsupervised is even more unspecified. So find patterns in the data, whatever that means. So let me just give you some examples of what kind of patterns people look for. Clustering is a typical canonical kind of unsupervised problem. Another one is what's called density estimation. And I'll mention a third one. There's probably many more, but a third type of unsupervised learning is what's called dimensionality reduction. So clustering, say we get, again, say we have some points in two-dimensional real space. So let's say that these xi's are in R2. Just a simple, these are all, I'm giving you some very low dimensional examples that we can visualize, but usually interesting machine learning problems come when you have these points are in very high dimensions. But let's say that it's just an R2, so we can draw some pictures, and maybe we get some points like that, some points like that, some points like that, maybe one over here. And your task for clustering is to find the clusters in this data. So I drew it so that you could very sort of easily visually identify some clusters. So you might say that this is a cluster, and this is a cluster, and this is a cluster, and this is some weird thing, maybe that's its own cluster or something like that. And there's all kinds of ways that you might imagine solving the clustering problem, and there's many ways to go about it. Density estimation is a little more, well, it's much more well defined actually. It's so for density estimation, you want to you assume that this data, so you're given, same type of setup, you're given some data, say they're in R2, and your task is to, so you assume that these data come from some probability distribution on R2, and what you want to do is you assume they come from a probability distribution with a density, and you want to estimate that density. So let me draw a 1D example. So if the xi's are just in R, and we got points. Maybe we get a bunch of points here, and then we get only a few points here. So we get lots of points there, a couple here, maybe some more over here. Then you might estimate the density by something small, and it goes up, and then you say, oh, okay, it's big here. And then it gets small again, and then there's a little bump. Something like that. So that's a density estimation. Becomes much more difficult in higher dimensions. And the third example here that I gave you of unsupervised learning is dimensionality. Oh, I didn't finish writing it. Dimensionality reduction. So dimensionality reduction is so say here's an example data set. Say we're in R2 again. Say that the xi's are in R2. So this would be like the first coordinate, and this would be like the second coordinate of each of these points that I'm going to draw. And say we get some points that looks like something like this. So each of these little dots is a point. Maybe they look like that. So you get all these points. And now your task in dimensionality reduction is to find some lower dimensional space that you can represent this data in. And I drew it very suggestively here so that you could see a sort of one-dimensional manifold, to use the jargon, one-dimensional manifold that this data lies on. And so you could map this to the line, and each point would be projected onto this line that I'm sort of outlining with the cursor. So the data would be projected onto the line. And that would allow you to understand the data better. So that in this case, there's low dimensional and you can just see it. But if the data is very high dimensional, oh, I meant to say R2 here. Each point is in R2. So, but if it was a very high dimensional, like if this was, each data point was in R10,000, and you could reduce it down to, say, 2 dimensions, then that would be very nice. And not only do you want to reduce the dimension, but you also want to preserve the structure of the data. Of course, you could always project it down and just mess everything up. Like if I projected it this way, say if I just took the x1 coordinate of this data, well, that's a one-dimensional projection, but then we're saying that this point and this point and this point all have the same projected value, and that totally destroys the structure, this interesting structure. So those are some unsupervised learning problems.